Rich Fox. Rich, please introduce yourself and let's share with the audience the work that you're doing there in Ohio.
Thank you, Sharon. Appreciate it. Rich Fox, the Ohio Aerospace Center. We're a division of ODOT. Part of the division of ODOT, one is operations side of the house. I'm on the research and development side. The operation wing has 35 aircraft that we fly in support of the infrastructure in Ohio, and the R&D portion is the infrastructure we're going to talk about tonight. When we talk about infrastructure, Ohio's taken a position of leading. We understand that the traffic's growing faster than population and our roadways are very expensive to maintain. So as we look towards the future, we look at advanced air mobility to relieve some of the pressure on the ground infrastructure and move some of that technology into the air. What I'm going to talk about tonight is multiple efforts that we have for infrastructure enabling advanced air mobility. The first one is called Skyvision. It's an ongoing test. It's a collaboration of Air Force Research Labs and the state of Ohio, the Ohio Department of Transportation, to integrate unmanned aircraft into the national airspace system. We work from 1,000 feet above the ground to 10,000 feet MSL. And in the lower right-hand corner, you can see the footprint of the airspace that we operate in. This is basically a sandbox for companies to come to Ohio and demonstrate their capabilities, test their capabilities. And ODOT is all about infrastructure. We build that infrastructure. So we want to be engaged with the equipment manufacturers, the aircraft operators, so we can anticipate the needs of what that infrastructure is going to look like in the future. It's based in Springfield, Ohio, Springfield Beckley Airport. And what we've done is we've integrated the same system the air traffic controllers use every day, separating aircraft in the national airspace system. We have a radar feed from Dayton International Airport, one from Columbus Airport, and there's one called the London Long Range Radar that Indianapolis Center uses. What it does is brings the picture of manned aircraft, both that are cooperative, meaning they have a transponder, and those that are uncooperative, those that do not have a transponder. And what Skyvision is able to do is takes the telemetry from the unmanned aircraft and it creates a target on a radar screen so we can watch it maneuver through the volume of airspace, and then we talk to the remote pilot and have them move away from the manned aircraft. We satisfy the 91113 Bravo requirement for see and avoid, and we do that electronically. This is a picture of the footprint from the top down, looking at the area that we cover. This is Springfield up here. This is over towards London, Ohio. This is an example of a alerting system that we put around an unmanned aircraft. You can see it's yellow. It's a quick differentiator from manned aircraft that are blue. This is the nominal state when it's not in an alert. When it sees a threat coming towards it, it'll turn red. And as the operator of the system, I will talk to the remote pilot and tell him to move away from this threat here. So there's two operators in the bus. The Air Force Research Lab holds the COA for this asset. And we work with the Department of Defense as well as commercial entities through a cooperative research and develop agreement for companies that want to come to Ohio and work with the Air Force to get into this airspace. So that's one effort when we talk about infrastructure. Second effort we have is called our Unmanned Traffic Management Program. This is an ongoing project. It's a multi-year project. It's on the Smart 33 corridor, which was in the news cycle just recently. It extends from the Transportation Research Center in East Liberty down through Dublin and into downtown Columbus. What we've done here, the Ohio State University is a primary investigator for this project, and the Department of Transportation has an effort called Drive Ohio. That's for autonomous vehicles on the ground. And at the UAS Center, we represent the flying portion of it, FlyOhio, and we're integrating both ground and air vehicles along the smart corridor to demonstrate the capabilities of last mile package delivery. So the infrastructure includes multiple radars. We have one based at Marysville, one at the Ohio State Airport, and lastly, one at the headquarters on top of ODOT. So this corridor is equipped to provide a detect and avoid feature for operators for last mile package delivery. Currently, the regulation for the FAA is you have to see manned traffic and be able to detect it and avoid it. So Skyvision is a ground-based detect and avoid. This is another ground-based detect and avoid effort as well. Our next effort is remote digital towers. It's conceptual at this point. We are working with Jobs Ohio and our legislators. There's a pilot program that the FAA had introduced back in 2018 to demonstrate this technology. Basically, remote digital towers replace the brick and mortar towers that we're accustomed to seeing at airports, and they do it electronically. They replace the out the window view that the air traffic control would do with cameras. So our effort is going to concentrate on academic institutions that have flight schools, starting with Kent State. We're going to then go to Bowling Green, Ohio University, and as well as the Ohio State University. The significance of this is this infrastructure not only supports manned aviation, but the integration of unmanned aviation as well in controlled airspace. And it elevates the safety footprint when we're training pilots that they become better trained and more prepared for the job market. So this is just a picture of where we anticipate deploying this technology at throughout Ohio. The next effort we have going on is called Combined Air Sensor Network to detect lower altitude aircraft. Basically, it is an effort to come up with a universal format when someone wants to deploy this technology within the state of Ohio. The reason we were doing that is because think of all the different cities and states that would want to deploy this technology, whether it's acoustic, a radar. We want to have that capability of ingesting it into an operational center environment so we could distribute that across the state of Ohio to support beyond visual line of sight operations. That's the ultimate goal for us. We want to be that clearinghouse for all that deployed sensor technology across the state. So this is an example of what we'd be looking at, optical RF sensors, radars, bring them into the ops center, then turn around as a clearinghouse and push it out to federal entities, state agencies, local agencies, and then the integrators for the advanced mobility software people. Next effort is with NASA. It's the infrastructure to build the facilities that are going to support advanced air mobility, landing and takeoff. NASA has a regional modeling tool for vertipads. On the top of the screen, you can see the name changes a little bit depending on what it looks like. A vertihub is all different type of modalities together with multiple flights landing at the vertihub. Then you have a vertiport in an urban environment where it's a little bit smaller because it's on a roof. They have two landing areas and they are able to maneuver the aircraft around to accommodate passenger access or cargo access. And the last one is a vertistop, a very smaller footprint that would go into a urban or suburban community to facilitate the advanced air mobility, connecting those communities to that infrastructure. So this is an ongoing effort with NASA, and it's important that they have worked with us to identify 7 candidate sites within Columbus metropolitan area. And once we do that, we're going to build them out for the rest of the state. Here's an example of going from Toledo, Cleveland, Columbus, and Cincinnati of some of the flight paths that they anticipate. And the simulation helps us identify what tracks are the most effective and what we could anticipate in the future. Lastly, the advanced air mobility ecosystem partnership strategy. NASA is working a national campaign. If you haven't heard of it, I suggest that you research it. It's the integration of both vehicle partners, airspace partners, academia, such as yourself. On the bottom side of the coin, we have professional associations and standards, state and local. That's where ODOT comes in. We are building this infrastructure. So we've been selected to participate in a national campaign, and it's a community integration relationship where we're going to hold in the next 3 years multiple focus groups across the state to roll out this technology, show people what it looks like, have demonstrations of aircraft, static displays, have them into simulators, so we can advance the whole methodology of what advanced air mobility looks like now, what the future is going to be, and what it holds for Ohio. And lastly, when you look at the market opportunity, the Ohio Department of Transportation conducted a research effort, and the numbers that came back are staggering. $13 billion worth of economic activity, 15,000 jobs, and $2.5 billion in tax revenues. When we talk about building infrastructure, it costs money. With this effort, this is a way that we can finance it and hopefully have a partnership with commercial entities to support some of that expense. So that's the end of my presentation. This is a quick roadmap of where we are, where we are going, and where we ultimately want to end up is creating that infrastructure for companies to come to Ohio and advance this technology so we can relieve the congestion on the ground infrastructure and be prepared for the future of aviation. Back to you, Sharon.
Great, thank you, Rich, for that presentation. And while Lisa is setting her presentation up, a quick question. You mentioned that you're going to be doing focus groups over the next couple of years. What's the long game in terms of once those focus groups are going to happen or happened, how long before we actually see a rollout?
So for rollout, I think it's going to cargo. We're going to see cargo first because they have the deep pockets to support this type of effort. The focus groups, the whole purpose is who knows their community better than local people, right? You know your backyard, you know what you want in your backyard. So we want to feel people out and expose them to what this technology is, get their feedback and kind of mold it as we go down the road.
Great, thank you. And thanks for your presentation.